Now, part 4. Let's enjoy solving this problem. Uh, Sketch the region and find its area, if the area is finite. Don't worry, it will be finite in this question. So S equals xy such that x is less than or equal to 0, y is greater than or equal to 0, less than or equal to e to x, okay? So here you draw e to x, it's easy, okay? And x is less than or equal to 0. So you just have this side, the left side of the x-axis, okay? And what more? You have y is greater than or equal to 0, less than or equal e to x, okay? So this is our region here. Yes. Nice. You may ask, what is this? I mean, is it related to 7.8? Yes, of course. Don't you see? It's limit from, let's write it. It's limited from that thing. So integral minus infinity to 0 e to x dx. You should put the absolute value because you are calculating area. But e to x is positive. So do I need the absolute value? No, because e to x is already positive. But in this area, you can solve it two ways, and we will do that. What is the other way? Like this, integral 0 to 1, absolute value of ln y dy. Why have I put here absolute value for ln y? Because ln y is negative between 0 and 1. So you need to be careful. And this equals minus integral 0 to 1 ln y, because ln y is negative. I mean between 0 and 1 ln y is negative. To make it positive, multiply by minus 1 and remove the alpha. So we can solve this problem using these two ways. Let's solve it using first this way. Integral minus infinity to 0. So best, copy and best. Okay? Copy and best, you are the best. What to do now? Yes, it's easy. It's just limit as t approaches minus infinity integral t to 0 e to x dx equals e limit as t approaches minus infinity e to x from t to 0. So this equals limit as t approaches minus infinity 1 minus e to t. E to minus infinity, I mean, when you take the limit as t approaches minus infinity, e to t is 0. So you get just 1. And note the area is positive, and our answer is positive. Okay, 1. Now the other way. The other way is hard. Not hard, but I mean, the solution is longer. Let's see here. How to solve this nice integral? You should remember that we have problem here at 0. So this one here equals limit as t approaches 0 from right of integral t to 1 minus integral, because we have minus sign, ln y dy. Now what? Now we will use integration by parts. So u equals ln y, dv equals dy, v equals y, du equals dy over y. So this equals limit as t. I want to solve it before without these things. I want to solve it without them, okay? I want to solve the integral, just the integral, then I will continue the rest, okay? Ln y dy. So integral ln y dy equals y ln y minus integral dy. And this equals y ln y minus y plus c. You see? So now let's solve this one. You get limit as t t approaches 0 from the right of minus, because we have minus sign here, y ln y minus y from 0, not from 0, from t to 1. Let's substitute limit as t approaches 0 from the right. You have minus, substitute 1 now. You have 1 times ln 1, 0. So 0 minus 1 minus t ln t minus t. Very nice, right? So this equals limit as t approaches 0 from the right. Here you have minus 1. With minus 1, positive 1. You also have minus times minus, minus, plus. So plus limit as t approaches 0 from the right of t ln t minus t. So now this limit here equals 1 because it's limit of constant, plus limit as t approaches 0 from the right, t, take t as common factor, t ln t, t times ln t minus 1. And we will use L'Hopital and Bernoulli. 1 plus limit as t approaches 0 from the right, ln t minus 1 over 1 over t. So let's use that L'Hopital rule. So equals 1 plus, now L'Hopital rule. Limit as t approaches 0 from the right, 1 over t minus 1 over t squared. This here inside the limit equals minus t. Good, good. Take the limit as t approaches 0, it's 0. So we get 1 plus 0 equals 1. Now the next problem. Use convergence theorem to determine whether the integral is convergent or divergent. And that's very nice. Let's solve it. Like this, x over x cubed plus 1 is greater than or equal to 0, is less than or equal to x over x cubed equals 1 over x squared. Okay? Remember here, we are integrating from 0 to infinity. So these functions are positive from 0 to infinity. I mean strictly. I mean when x is greater than 0, less than infinity, here x less than infinity means that you can go to any number, any positive number, and these functions will be positive, okay? So now, by this here, p is greater than 1, so it's convergent. So convergent, because b is greater than 1, b equals 2 here. 2 is greater than 1, so convergent. And this one between them, I mean x over x cubed plus 1, it is also convergent. And this is part 4. Please like and subscribe and write comment whether you understand or not. Of course, you will write that you understand. I know that. I know that you will write this if you watch this. Good luck.